Hi, my name's Arman Patel, and this is our CS 180 project. It's a reservation management for a theater, and along with me, it's Arman Agarwal, Emily Zid, Tony Chen, and Alan. Those are my group mates, and this is what we made. So, for our pitch, we had a vision of streamlining movie theater reservations. Um, when you go to reserve at AMC and a lot of these other popular retailers for, like, not retailers, but movie theaters, it's not as straightforward as a process. There's a lot going on. And so we wanted to make it simple where users can easily log in, uh, pick out exactly what they want to watch, see their reviews of that movie, see how long it is, see a little description of the movie all in one place, and then select the showing that they want to see, and then add and book seats. Along with that, we also wanted to make it really easy for the admin, where they can also really easily add movies if they like. They can edit things. They can edit the type of showing. They can edit the seats offered in that showing. And not all movie theaters are the same, right? You might have a different seating arrangement for one movie because it's more popular at the time, and a smaller one for another one that's been out for a while. Not as many people are going into it. So you don't need as big of a movie theater allocated. And so our system is designed to adapt to this, where you have multiple different settings for how big the movie theater actually is. Some are just 5 by 5, while others could be 20 by 20, right? It depends on the showing itself, giving the admin lots of variety and lots of ability to customize exactly how they want it. So some of the design choices that we had was number one, we have a client server reservation platform where all the data lives on the server. This especially helps us with the real time tracking, where if somebody books a seat, it updates real time to show you, hey, that seat is actually taken now, right? This doesn't happen as when I've been trying to book movie theaters, book seats for movie theaters. I'd click on a seat, go to checkout, and then oh, the seat's taken. So it doesn't show me real time what's happening. Our software actually does that. Secondly, functionality. Users can create accounts, log in, browse movie showings, and book reservations. They can all do everything from one account. They can see all of their previous reservations. They can see all of their upcoming reservations, and they can even edit reservations. Three, scalability. It's very easy to expand, has a thread design, server-side structure, and supports large amounts of data. The way we made it is it's very tileable, right? You can add as many more instances as you want into it, and it's very easy to expand from the design. You could have multiple concurrent users running all at once, and it is a-okay. Nothing would happen to it. And so that's something that we really wanted to prioritize because there's going to be a lot of people using movie reservation systems at once, right? There's not going to be only one person using it. And so that's something that we wanted to put some emphasis on.
Real world reliability. When we were building the system, one of the main things that we focused on it was to make sure that it could handle real users doing real things. So we designed it to be robust, enhanced, reliable, and efficient. And each of those plays a role in how well the system works. Starting with robust, the system can handle multiple clients at the same time without any issues. If several people try to log in or try to book a seat at once, it doesn't slow down or crash, especially. It just processes everything like normal. We also make sure that it's protected against invalid requests. If someone tries something that doesn't make sense, like it booking an out of range seat or sending a wrong input, the system it doesn't break as well. It handles the error and it keeps programming and stays stable. Next up, enhancement. All the data is centralized on the server. That means every client is always seeing the same up-to-date information. Um, we also beat, sorry, not beat. We also built in serialization so the server can save and load the entire system state. Even if it closes or restarts, nothing gets lost. And accounts, showings, and layouts and everything is all saved and preserved. For reliability, we made sure the system prevents a double booking. So if two people try to choose the same seat, even at the exact same moment, only one of them gets it because the server handles everything in a thread safe way. We've also tested the system uh, in multiple times across in multiple users and in logins just to make sure it always behaves the same and doesn't produce any errors, crashes, or those wrong side effects. And lastly, efficiency. The UI updates smoothly without any unnecessary loading or lag, so users don't feel like they're waiting on the system or it doesn't take too long. And we also avoid redundant calculations. Um, and yeah, so overall, this system is built to be stable, um, or a robust, enhanced, reliable, and efficient. Something that not only works, but it works well when people try to use it. So it's user interface friendly.
Hello, I'm Tony, and I'm going to do the demonstration for our project. So we're going to go into a terminal, and we're going to compile theater server and theater client.java. I've already done that, so I'm just going to run theater server and Java theater client. We get an authentication screen where I'm going to sign up as John Doe 123. So we're logged in. I've already ran this program before, so there are some movies in here already. So I'm going to click Garfield, and Garfield has two showings, one on December 30th and one on February the 1st. So we can book movies as far as to 3 months in advance. So I'm going to book the February 1st one. You can select a few seats. You can see that there's different types of seats: premium seats, standard seats, recliner seats. So I'm going to select a few premium seats and book them. Checked out. And now you can also remove seats. If you need to see the seats properly, you can full screen. And then you can also, we can demonstrate something else. We can demonstrate the real-time updates by making another account. We'll go as Jane Doe 123. So this time I'm going to also go to the same book showing, and we can see that the seat is already taken because John Doe took it. But what if we take these seats? We can see that it updates here too. And let's just cancel this reservation, and we can see that these seats go back to normal. So here I'm going to demonstrate another of our features. So here we've booked a lot of seats. We've booked almost every seat in the entire theater. So you can see that normally the standard seats, which are in the last ones here, they are $8.10. So 5 of them would be $40.50. However, due to variable pricing, the greater the demand, the greater the price. So if we go into another tab and we reserve the same showing, we can see that it becomes much more expensive, and almost twice is twice the price. Now if we log out of here, and let's see what we can do as an admin. So for our program, the admin login is, the username is admin and the password is admin123. So here you can view your movies and you can create new movies. So let's say we want to create a new movie. Elements, you can set the ratings. Let's set this to 3.5, and duration in minutes. Let's set this to 200. And you can enter any description. I don't really know a description right now, so I'm just going to enter ABC. So it won't show up yet until you create showing. You select a date for it. And you can select multiple layouts. The default one is 5x5, which is 5 rows by 5 columns, but we can also have 7x10. And you can go in here and reserve seats for special parties by just doing this. And the same as usual, you can remove seats. We've already shown how you can do that. So we can also edit prices for standard seats, and that's base seat pricing. So it can change to 15, changes to 20, changes to 30. And yeah, that's pretty much it for the demo.
Okay, so testing. For testing, we had 4 different types. Type 1 was thread safety. We made sure that the server could support multiple clients and avoids double booking. So, for example, 2 people can't book the same seat. It makes sure that if someone books the one seat, when the other person that's simultaneously trying to get that same seat gets a message upon checkout that it's already been taken. And type 2 was dependable database. So we ensured that corrupted or missing files fall back to a default user manager. So basically, all errors for the database can only possibly happen in one place. And we handled all errors in that one file. Test 3 was GUI display precision. So we ensured that when we display anything to the client, for example, showtime, seat availability, reservations, they are formatted correctly and uniformly across all types. So the admin will see something similar to what the client will see. We had a uniform language across our GUIs, and also uh, we made sure that there are no errors on display. And finally, test 4 was all about performance stability. So we optimized the looking up users, showings, and reservations, so it doesn't take extremely long to search for any user or data that might be needed at any particular step.
So let's start with questions. Question number 1. How scalable is your system if the theater expands to thousands of daily users? Our answer to this is that our system is inherently scalable because of our thread-safe design. Each major responsibility is located in its own compartment, allowing for adjustments to be made easily without having to rewrite the entire code. Movie showings, users, and layouts are all managed by specific classes, so the GUI can display this data on demand. If the theater expands, we can simply load larger datasets or add more showings without restructuring the system. Because our system is centralized, long-term scaling is not just possible, but expected. Question number 2. What makes your system reliable from a business standpoint? Reliability comes from 3 deliberate design choices we made: organized storage, clearly separated logic, and consistent input validation. All user and movie showing data is saved on every run, meaning that no manual backups or re-entry is required. The separation we keep between our GUI, backend logic, and file I/O ensures that one component cannot break the others. Our system is built with maintainability in mind. Additionally, we safeguard every user action to prevent invalid states. These choices all reduce operational risk and guarantee predictable behavior even if heavily used. Thank you.